Okay, now we're at part 2, and we just discussed the condensed matter ordering under the Puchta chains, respectively Cooper Puchta chains, changing the area inside the condensed matter from carbon-12 that's imposed on the metal from an oxide during the forging process, right into graphene within the lattice of the metal. Edmund Storms, the aficionado of cold fusion, come to the conclusion that the cold fusion happens in the crack. Yeah, the breaking of the Cooper pair crack. Well, we basically made a 4-lane highway out of a walking bridge in the same area of a walking bridge because, once again, carbon is 900 nanometers squared density, volume, and graphene is 2350, theoretically, density, volume, until you stack plate the graphene. Do you understand? Not in a row. You've now stacked the Cooper chains, and that's the reflection that you see on the oscilloscope, allowing you 2 lanes of highway now, both lanes, because of the properties of graphene and the bipolar PNP transistor properties, allows you to go both directions at one time in graphene. So now you've got 4 lanes, 2 lanes going either way in the same path, in the same volume, because the specific weight of graphene is 12.01, same specific weight as carbon-12, which tells you that I'm telling you that I'm taking carbon directly into graphene, making carbon the allotrope of graphene, not graphene, allotrope diamond, allotrope graphite, isomer graphene. Allotrope is the carbon. Graphene is the base. Once you impose an electron, what happens? It drops the shell of graphene in a combustion process or a forging process down to carbon-12. But it officially was graphene to begin with. Superconductivity. Gravity is superconductive, and now you're seeing the amplification of superconductivity. Okay? Now, let's see how we test a dead short. We take the same power and going to go directly on this capacitor bank for safety. Yes, I can no problem dead short it. Boom. That's a dead short. There's my wire. I specifically use small wire connections for safety, so they shunt. Now, the wire that's the core is only 30 thousandths. This is basically radio wire, which is probably more like 7 thousandths. This goes over to the generator that we're going to talk about next, that you've been watching in the 4-phase power. Okay, so that's dead short. Now we're going to go into a set of capacitors. What happens? Oh, okay. Can you please turn on the switch? There's the light. Okay, that's it. That's all we're using. We're not using any more power than that. About 21 watts. We'll talk about that in a moment, because I'm being very conservative in the calculations that I'm giving you at 1.6 ohms, because that's the ohms of graphene. But that's not the truth. Let me show you how we calculate that. Let's put this back down, and I'm going to disconnect this for a moment. Okay, we're not even going to turn off the power. You see that? No arc. Now, we take this red hot electrode, we come over here, and we touch it on this coil, okay? So we can induce the energy to this coil. Then we take these 2 leads, and it's connected to the capacitive meter, which is connected to the impedance meter. So we know exactly the frequency that we're imposing on the wire. Now we take that with redundance and we focus that into an audio generator backfeeded so we know exactly what frequency that we're at. Then we redundant that. You see these neodymium magnets, okay? This is stainless steel, but stainless steel, even stainless steel, going through electrolysis process will become magnetic. At the tip of this metal, there's no magnetic. But as you go up the metal, it's definitely magnetic. You see that? It's definitely magnetic. So